Come on, hon, stuff some merch in there.
Then there's, gosh,
Okay, well, we're a bit into this, Ben. We're going to need to slow you down just a little bit here. But while we're on the subject matter, real quick here, we're dealing with a probability distribution before Ben Eater goes full adder on me and just breaks it down to the quantum level. Um, he's taking this thing, he's going to make some logic trees out of it. Real critically important to understand why probability and some of this initial entry stuff, because what a 1 and a 0 is not a 1 and a 0 when you do something like the trade triangle with the Ben Eater one I was doing earlier, wave function 1 to a medium of a higher, tighter frequency where energy can make a lot of explodies. We'll just let her go.
Hi class, we are here to discuss multivariate random variables and distributions. And so let's begin with the simpler case, which is the discrete world. Suppose we...
Okay. The discrete world being the simplest model I can posit to do here is the atomic level, classical physics A and B, and an X, Y, and Z. Well, we need a space that's X, and we need a place to put the object or statement. So those are your basic two simplest discretions. I need that there, and in this form, for whatever reason, one of those wires is that, two of those wires is that, and eventually that'll get me there with 1 to the 7 that this has. Magic. That describes what you're dealing with and why it's important in one of these forms. It's back to your operating systems of Droid or Apple. Just I have the two cheapest versions you can possibly buy. Oh, I'm not saying that these are cheap, and I do not miss. All right, so discrete distribution here on what happens, but I only have what that is. Maybe I could buy some Alienware someday. I can get up in here into one of her classes and hopefully do her better. And but this isn't bad. This is a pretty discrete distribution of people that like it, take your heads and tails.
We have D, discrete random variables.
And how in her classroom she would be very direct. I couldn't be able to do this in a classroom like that because that's not very respectful to do something like that to Ben Eater. But what we'll all be doing, because we all share this similar field charge here, is some model of describing why the logic has to be either a physical analog, an I hat, J hat variable on that, or the other. If this was the other way, then the other way. And because of that math, you'll get this distribution, which starts to form something, heads and tails, at this very base system that gives me enough room, X, Y, and Z, to actually say, well, that probability actually gives me something different, Y15. And therefore, Y15, 0 through 9, which is 10, 11, 12, 13, 14, 15, 16, excuse me, and 0, 0, 0, which might be a very different type of code with the logic that might be inputted into it, when here the 1 and 0 is not in any of that configuration, but has entropy to value of what that 64-16 game is, about why math works the way it does, of factorials and fibicals. And again, I wish I could just let it go. I honestly could, to sit through one of these would be nice. I guess I don't have the right field charge to help me do something like that when this isn't keeping my hands and mouth shut. As far as the MRI on Jake Sully's brain pan here, it makes it very incredibly difficult for me to hook in. I mean, I now I know I got to buy this, and the only other way to do that is to take it down to the breadboard. Once you take down the breadboard, you take it down to Copper Wire Factory, you take it down to Lindengraf machine and what is it, Lindengraf? What is it, Van de Graaff machine and a Linden jar, because that is where the housing of the Dakota hole could be very practical between A and B in certain wave functions. And yes, the program, while in this form, could be an amazing counter that I don't ever have to worry about forgetting the numbers, the paperwork getting wet. I can send it to this other place, which is fantastic. In many ways, IHAT and JHAT very incredibly useful. In a way, you can't just describe that in a discrete distribution. You can't describe that in a binomial. Trigonometry, if left to the calculus and the ball, is a very good version of that. Slipping in and out, and you get a lot of this kind of tone to a fortement, whoever's going to listen to this. All I'd have to do is hit the go button and on both of them at the same time, and some interference patterns and things are going to come in. Just in the fact that in a multi-worlding universe, QPU here, quantum computing, I burn calories, live off coffee, and that seems to do the heat equation for me, Laplacian to the Gallows theory of how long that equation really is. Here, I just need a square root, but I ain't got one, so portions of that very segmented wave function is light. And when C is the value, heads flipping coins, tails doing something, that's going to give me the number of pixels on that Game Boy cartridge I have to limit it to. May not necessarily just be a Nintendo thing or a JavaScript thing, a NVIDIA kind of a deal. It's something you have to really kind of consider as far as the operating procedures of that bunny farm there. And I've just things I'm trying to keep an eye on.